Okay, I'm recording. So today we are going to learn a link about linked lists. Okay. So before we go for the linked list, let me just explain to you what is an array that you usually learn before, and how does linked list differs than an array. Okay. Apparently, I don't see any. Isn't it Microsoft? I should be sharing. Just share my whiteboard here. Okay. Can you see my screen? Hello, hello?
Yeah. Your
Okay,
screen
okay.
is showing, but it's a whiteboard. Just
Okay.
whiteboard. It's showing.
Okay, good. Okay, so what is an array? We've if you have learned programming before, you have pretty much know about an array, where it is just basically an array, or you can imagine it like a not closet, like a rack of books, where you have some like a index, like index 0, index 1, index 2, index 3, index 4, 5, and 6. Basically, an array have a fixed size, where when you want to initialize an array, you have to tell the array how large it is before you are going to put your elements inside an array. So when you want to access an array, you can, since you already told the array, the program, that okay, this array is a size of 10. So they already know that okay, from 0 to 9, because let's say we have 7, 8, and 9, from 0 to 9, so these are basically the storage where you put your data inside the array. So when you want to access, you can directly access which position in that array. When you want to access the data, you can just tell the program, okay, I want the data from this specific position in the array. However, array have some limitations, okay, where let's say if you want to store so many data, but your array is just this size, you cannot store that much. There might be some memory overwriting. So what do we do is that we introduce a new one, a new kind of list, okay, where it is basically a more dynamic one rather than an array, where a list is basically consists of a node and its pointer. So this is a node. In this node, we have one called the data, and this is the pointer. Or you can also call it as a link. The data means whatever we want to store in that particular node. The pointer is what connects this node with another node. So this is the second node. So this is node number 2. And then where we have a data and also a pointer. But sometimes this pointer does not have to point to any other nodes, so it can point to nothing. When it points to nothing, it means that we have reached the end of our list. Okay? Now, how do you want to access this list? Because first, it doesn't have any fixed size. The size is dynamic, and you can't just immediately access each of all nodes. So what do? We have a special one. We call the initial, we have a special pointer. This is what we call as a header or a header of the list, where it points to the first node of the list. So if you want to make it a bit, if I want to make it a bit more tidier, So this is the header, which is a pointer. It points to a node that consists of data, maybe data A, and then another pointer that points to another node, which is data B, and then maybe another one, data C, data D, and maybe we want to stop here, like that. Now, speaking about linked lists, there are, other than having a header, we can also have a tail, a head and a tail. So what do we do? The last pointer might points to the tail, meaning that you can also tell the program to create a list that have a header, a head and a tail, the start and the end of the list, so that when you want to do the programming, when it reaches the end, so the program knows that it has reached the end. There are why do we need the tail? Because sometimes we might want to access the list from the reverse order. But in this lab demonstration, I'm going to just focus on the header only. No tail is required. Okay, just the header and the list itself. So how do you want to do this? How do you want to build up this linked list? Okay, let me just open this. So we'll start with the basic one. So what do we do? First, we introduce a node, the nodal class. Oh, I forgot to introduce you to the class. Okay. So basically, what does this class mean is basically a template where you can put all the required it's basic. If you haven't learned about C++, but basically a class is a template of an object, where you can have a class is basically what do you call it? You can define a class where that class is going to be used by several different objects that share the same characteristics. For example, let's say in a class we have students. Students are so in this program, in coding, in programming, the student, the entities, the template student itself is the class. So what can a class student have? They can have a name, they can have a gender, they can have what they call it, grades, they can have their age, they can have their heights. Okay, but when we want to introduce a new student, an entity under the class of student, you can have a student that is named Haziman, or you can have a student that is named Lukman or Shukri or Zikri, but they are all different students, but they are under the same category or the same class, which is class student. They can have the same grades maybe, but they can have a different grades, but they all share the same same characteristics, same functionalities. Same goes with this coding. So in this class node, we are basically preparing a template of a node, which is this one, a node. So this node, as you can see here, so the first one is what we call a constructor, meaning that when we want to initialize an entity using a template or using a class, we want that entity to have data, and we want that entity to have a link. Okay, so what do they say here? Def initialize self meaning that it refers to themselves, comma, data equals to none, link equals to none. As we have learned in our previous class, if we have this if we have this assigned inside the parameter, it means that if we are creating a node from nothing, basically you are making them default to nothing. If we want to create a node and we want to give something to them, then we would say, okay, I want you to create this, and I want you to create, I want you to use what we have given to you as your data and your link. So this is the first one. The second one is basically the basic user-defined operations of a node, where we need to update the data, meaning that we need to assign the data to the node itself. Second, we need to assign a link, meaning that we want to attach this node to the other node. Okay. And then the third one is we want to remove the link, meaning that we want to detach the this node from the next node that it is holding. That's why we are going to put it as self.link equals to none. And then we have get data, and get next is basically you want to retrieve the data from the node itself, like that. Okay, so this is the template for the nodal class. This is not the linked list yet. This is just the node itself. The what do you call it? The storage, or the what do you call it? The index of the link list itself. Okay. So do you guys understand about the node class before we move on to the linked list class? If there's nothing, then we'll just proceed. Okay. So for this one, we are going to we want to create a class linked list. When we initialize, we want to introduce a header, self head equals to none. What does this mean? It means that the list is empty. There are no nodes. There are no nodes inside the list. Okay, so this is this one, the header. Now, if you have seen, there are a bunch of some codings here. So let me just do all this stuff. So class node. Let me just this one. So define underscore initialize. Okay, comma, data equals none, link equals none. Okay, so self.data equals to data, self.link equals to link. And then for others, let's see, what's the name of the set data, for example. Set data, self, comma, data equals to none. You can also ignore the data. Okay, update data. Okay, so update data. We can just use set data. And then self data equals data. Define set link. Self link. Self.link equals to link. Define remove link. So basically you want to set the link equals to none. Dot link equals to none. Then we have get data, return self.data, find get link, return self.link. So this is the class. Okay. So what we are going to do is that introduce another one, which is a class of linked list, LL, define, initialize. So this is basically we want to initialize the link itself. So self.head equals none. Now we want to, so we already have our linked list, but the linked list is empty. So we want to add something to the list. So how do you want to add the list? This is where I want to teach you. There are several ways you can add your list. It depends on what do you want. So whether you want to add the list at the start of the at the node at the start of the link list, or you want to add the data at the end of the list. So what happens if you want to add the data to the start of the list? So header. So there are several cases. Case number one, if the start of the link is empty, meaning that the header is empty, we can just assign new data to the header, like that. Okay, if the list is empty. Second, if the list is not empty, meaning that we have already have the header, so this is the old data, and we have a new data here. So what do we do? This is initially the link, right? So what do we do? We set the link of the new data to the old data, the first elements in the list. And then what do? We remove the link from the header to the old list and we assign it to the new list. So we can set up this. Okay. So what do? Define add to start. Okay, add to start. Let us just say data. Okay. So what do? If self head dot head is none. So if the header is none, meaning that there are no nodes in the list. Okay. So what do? Self head dot head equals node node parenthesis data. This is where we want to put the data. How we want to put the data inside the node and assign it to the linked list. So this is how we create the entity data using the template node here. Okay. So for this one, so LL, and then we want to do LL dot add to start, let's say 12. And then for the sake of printing, so print LL. Wrong one. Current file. Okay, let's see where did I get missing. Potential positional argument. Let me see. I mean, already have this one. This again. Okay. Define at to start, comma, self-hit. Oh, I forgot. list equals ll. My bad, it's been a while. List dot add to start and then print list. Okay, so what happened here is basically when you print out this, they have this. It just tells you that this is an object of something at a memory. So what do? We want to do this. Link dot head, and what did it do? A node. So it shows a node. The header shows a node. The header points to a node that is located at a certain memory. So let us go straight to the data and see what do we have here. We have number 12. So in other words, the list is basically a big, the big character, and we go to the header, or which is what it holds. So the header points to another node, and we want to see the data at the node. So this is just a problematic thing to do. So what do? Let us do. Let us print out this list. So define display self. Oh, before that, before we move on to the display, if somehow we want to add another one, copy, and then we paste 20, 36. Okay, how are we going to access all of these arrays, right? So if we want to do it like just a rough one, like print list dot head dot link and then dot data, we can get 36. Nope, it did not get 36 because why? We haven't finished our add to start function, because we just do if the self head is none, then self head equals to node data. So let us finish this. Else, so what do? Temp equals to node data temp dot link before that, comma self head dot head self dot head equals to node data self head. So let us try this. I forgot this one. Okay, if you run this, we get 20. So self head equals to node data comma self head. I think in my original one where I put the add to start, it's a bit different. Temp node equals to node data temp node dot set link self head, and then self head equals to temp node and then delete temp node. So in other words, we can do that. But for this one, this is this away. Method 1. For method 2, which is basically what I did for. Method 2 is that we create a temporary node. So node data temp node dot set link, because we already introduced the set link just now, and we go to self dot head, and then self dot head equals temp node, and then we want to delete the temp node like that. We can also do it like this. this is basically you want to delete the temporary node because the self head already attached itself to the data, the variable. Okay, because bear in mind the pointer is pointing the pointer is just the pointer, but the temp node is what we need. Okay. Okay. So let's say if we want to run this with the second method, we also get 20 as well. Okay. So you can choose which one. This one, which is looks simpler, but oops. But this one really utilize whatever is inside our nodal template class. Okay. Now we want to display this. Okay. We don't want just to access one of them one by one. We want to display all of the data. Okay. So what do we do? Let us introduce this display. So how are we going to do this? Is that so to display a thing, we will begin from the header as usual. And again, if the header is empty, we see basically the list is empty. But if the header has a node, it's pointing at. So what do? We go to the next node. Okay. So go to the next node and print out data within that node. And then we check the link of the node, whether it is linked to another node or not. Okay. So let us do that. So if self head is none, actually we don't need this. If self head, meaning that if self head have something on it, so what do? Print temporary what do you call it? Temporary node equals to self head dot head. We want to print out temp node dot get data. Okay. And then we check while before that, while temp node, okay, I think that's a there's a better way. So what we do, temp node equals to self head, while temp node is not empty. Sorry, I'm just going through so much optimization that you might not understand what I'm thinking. So while the temp node is empty, we print out the data it's holding. And then what do? We set the temp node to the other link. Temp node equals to temp node dot get link. Okay. And before, so if you run this, print with list dot display, if we run this, and we will get this, all this, 36, 36, 20, 20, 12. Okay. Why do they print out twice? Let me see. If you are looking at the display here, where's the display one? Display button, display list. Oh, I put current self head. If current is none, list is empty. Okay, so that's correct. while current data get next. Current get next is get next. Okay, good. Comma. Okay, if you notice in the original code, I have put n equals something like this, right? So what does this mean? Is basically we can change how we want to output our data in the log file. So if you put n equals to something inside, it will change. It will what do you call it? It will put the character that we want it to put at the end of the print line. So for example, if I want to put arrow like this, so you will get like this: 36, 36, 20, 20, 12, and then 0. However, I'm not sure how they got this one display itself. Tab node, comics. Oh, I forgot. Set link. Wait. Yalah, betul lah. So if I were to run this, wait a second. Man, current equals to current.get next. So I'm correct lah. Yeah, I'm correct lah. Although I do not understand how did they got double. Tab node. So let us just try this. If tab node is none, okay, none. So we say print the list is empty. Okay. Else oops, not this one. Okay, linked list. Rerun this. Oh, not this one, wrong one. This one. I were to run this. The list is still here. It's not double, but how come it's double there? I'm not sure about this one. Okay, but it's okay. Let's proceed. Okay, so we have learned about how to add. Oh, I forgot. I forgot that I put this as double. Okay. So let me just do this. So in the end, we have this 36, 20, 12, and then up to 0. So that's how you get. The reason why I got double is because I forgot to comment one of the methods here. Okay. Anyways, so we have done doing the tab node here. You can also do immediately like this. Just erase this and just put them output each of the data as they want. But it's on your creativity on how would you like to display the data. Okay. So while tab node, so print tab node equals to get data and n equals to whatever you want. Now let's say you want to find the total of this data. So for example, def count count size, or you can do it like count, for example. So you want to know how many data are there stored in this list. So you can do the same thing. You can copy this as you would do using Stack Overflow. Okay, but the difference is that instead of you print out the data, you set the data to something. Okay, so maybe you put count equals to 0. And for this one, while temp.node, instead of you print out the data, you count how many. So count plus equals 1. So you put list dot count self, and you got how many? I forgot to return the count. Print count. Like that. Okay. So get 3 at the end. And let's say if you want to do this, so print, just put another print here. So it makes it a bit more beautiful. Just for the sake of making this a bit more tidy. If tab node, the tab node is not empty, so print and with like that. So you get this. So you already do what? Add to start, display, count. Now we want to do add to end. Okay, so we have done adding the input, we have done displaying the displaying the data, and we have done counting the data. Now we want to do how we are going to add the data at the end of the list. So how would you do is that basically you can do the same thing as you can just copy the count data. So what do you do? So before that, let me just change this to return, so that you can change this to print comma count like this. And for this one, add to end. Okay. So if the temporary node is empty, it is basically what we can just add it to do it like we do add to start. So self head equals to tab node equals to node data, and that data is put here. Okay. Else, what do we do? While the temp node is increasing, okay, so let me just do it like this. If self data is empty, so self head equals to node data. Else, what do we do? Temp node, temporary node equals to self.data, self.head. Okay. While the self.head is not empty, before that, there's while what do you call it? While self temp.node dot get link is not empty, we move to the next one. This is you have to be careful with this, because I will show you what happen if you don't if you just do while temp node but not while temp node dot get link. Okay, so temp node dot set link node data. Okay, so basically what happens is that as long as there is the next node, we go to the next node. If there is no next node, meaning that we have reached the end of our linked list, so what do? We create a node and we set the link of the temporary the last element in the list to the data. Okay, so let me just show you. For example, this is header. So we know that if the header is empty, basically we just put it at the start. But if the header is not empty, what do? We go to the first node. So this is the temp node. This is the first node, but we consider it as the current node. So we check the next one. Does the next one have another node? If there is, then the temp node will move to the side. And we check again if there is another node after it. If there's none, then what do? We create a new node and we assign this node to the new node. Like that. Okay? And then we remove this. Okay, so let us try add to the end. And let's do this again. Display and list count. If you do this, okay, what happened? Oh, why do I put self.data, self.heat? My bad. So you notice that now, okay, just to make it a bit more clearer, 10, 15, 30. Okay, so if you run this, so now the 10 is added at the end, followed by 15, followed by 30. So this is what we call as add to end. And at the start is basically you put it on at the start. So that's why we got this. Actually, what you can do is that you can see how the process is going. So let's remove this. So when we run this, so you can notice 12 is added at first, and then 20 is added in front of 12, and then 36 is added in front of 20, and after that we add at the end 10, 15, and 30. So this is what we call as add to end. So that's we have add to start, we have done add to end. So the add to end is basically like this. Okay. So as you can see, there is another way. Basically, this is another way to do the data. Okay. Let's see. There are some things that you might have noticed here is that we have the push. The length is basically the count, how many data was stored in the list. We have the pop, we have the enqueue. Okay, for the push, pop, enqueue, and dequeue, we are going to learn in the next lesson, which is the stack and queue. But actually, it's basically, you are basically the add to start, add to end, yeah, and we are going to learn about how to remove the data from the list. So let us do that. Okay. So So there are several ways of removing data from the list, whether you want to remove from the end or remove from the start. Okay, so same thing, if you can use your logic. How do you want to operate this both functions? So remove from n is basically you get to the end and you remove the end only. Okay, if remove at the start, it's a different story. Okay, so if you remove from n, remove from n, this is basically what I did not this is what I did not teach the others. Actually, I can just remove the front only, right? I can just remove from front. You can try to do the remove from the end. Let me see what is the task here. At the start, display count odd, count functions, swap to elements. Max.
It's actually possible.
It's
Akmal.
actually
You can do it either way.
it's actually possible. It's just that I'm not I can show you one, but and you can figure out the other. It's just that it's basically I'm lazy to
Because
do
if
both.
you do it that way, it's going to give like a O of 1 for the complexity.
Mm-mm.
So meaning we are going to have 2 pointers,
Mm-mm.
one maybe to the tail, one to the head, or you can do it the other way around also.
Mm-mm.
Either is possible.
Mm-mm. If you have the tail, right, the tail pointer that I mentioned in the beginning of the class, you can straight away just delete the tail. But let's say if you don't have the tail and you want to do remove from the end, then it just takes some time based on the size, the length of the linked list. They have to go from the start of the list until
Yeah.
the end just to remove the end. So
Yeah.
for the sake of
Yeah. You
simplicity,
traverse.
they have to traverse. So for the sake of simplicity, let us just remove from the beginning of the linked list. So let us do that. So to remove the list, to remove the data from the beginning of the list, so remove data. So let me just comment this first. This is basically remove data from the beginning of the list. So what do we do? What do we do? Basically, self.heat equals self.heat dot get link. That's basically one line. But if you, let's say you are worried about the memory loss, what you can do is that you put temporary node equals to self-heat equals to temporary node dot get link, and then you remove the temp node itself. Remove temp node equals a temp node, a delete temp node. But let me tell you, there might be a problem with this. Since the class is since there's how many people are there here? Let me see. Oh, there are 8 people. So can someone tell me what possible problem that might happen if we just use this code to execute our remove data? Anyone? Let me give you a hint. What happens if the list is empty? There will be an error. Okay, let me just show you. If I were to put list.remove data at the beginning of the program, it will give you a an error because the node is not exist yet, but you insist of removing it. So what do we do? So we check if the list is empty or not. If self hit, then we can do this. Else, we print out the list is already empty. So if you run this, it says the list is already empty. So let us try list dot remove data, and we display again list dot display. So what do we get? Oh, I forgot L. It should be capital L. So you can see that 36 has already been removed because it is the first node in the linked list. You can try to do remove data from the end, but it will waste the program some time just to traverse the whole list to get to the end. I mean, just imagine if you want to do all this, like for example, to do add to start and add to end from the beginning to the end, and you want them to remove the data from the end of the list. So basically, you are wasting that time just to do that, just to remove the data at the end, which is unnecessary. You can just do it. You can implement the stack and queue, in which I will teach you in the next lesson. I mean, it's fairly easy, so I can just teach you now actually. Okay, so we have done add to start, add to end. We have done remove the list, and as you have noticed, there is a clear list, which is basically you set the header to none. So all those is basic. So let us implement that. Define clear list self.hit equals to none. So let us redo that. List.clearList, list.display, and what will happen? It says that the list is empty, like that. Okay. Is there anything more that I missed from my old coding? This is the coding that I used to teach the previous semesters, but since I want to refresh my memory again, that's why I create another one from scratch. Playlist, we have done that. So there are some other things that you can do with the list itself. Let's say if you are doing a list of numbers, linked list of numbers, you can try to find the maximum of the list. You can try to find the minimum of the list. You can try to get the range of the list, since you can do the minimum and the maximum. Okay, and this one is just hideous to see. You can find the total of the list with total of the values in the list. You can try to do the average of the list, and one of the hardest is you can check whether the list is sorted or not. Okay, there's also another one, sort increase. You can sort the list in the increasing order or the decreasing order. And there's also another one where I do find the data. Okay, good. Okay, I would show you all the, not, it's not unnecessary, but it depends on your requirement, but I can show you how to get the data from the list. Okay, so there, and there's also remove by index. I won't demonstrate to you how to do that, because you can implement that by using the tools that I will show you after this, which is the get data and the find data. Okay, so let us find the data from the list. Define find data, self data. So let us do this. So as usual, what we can do, if self is dot hit, So what we can try to do, let's say, let us try this, not this one, this one. We can try to do add to n first. Okay, if self head is none, so what we can do, instead of adding the data, since we are trying to find data, we can say print out the list is empty. Okay, else what we can do is that, okay, so we have the data here, right? So self.data, not data, data, we already have the data, right? Okay, so tab node equals to self.head. I don't think, is it? Let me just check again whether, okay, good. So let us do k equals to 1 because we are not, since we can define this list ourselves, so we can avoid using error by 1, meaning that the starting of the list is 0. So let's say the starting of the list is 1. So k equals to 1, type node equals to self head, and we check if the header is if the head is empty or not. Okay, while tab node, okay, this time we can remove the get link because we are focusing on the node itself, not the node after it. Okay, we can check if tab node dot get data is equals to data. We print out the data data is found at index k dot, and we go to the next one. Okay, so let us try this. List dot find data 30, 15, for example. If we run, oh, I forgot the list is already empty. So let me remove this. So this, I forgot to add, I forgot to plus the k plus equals 1, meaning that when we get to the next node, we increase the size. We change the k to 1 to signify that the index has changed. Let us do that. Instead of k, we do index. Index, and let's try again. So you can see the data 10 is found at index 3. Data 10 is found at index 3. And let's say if you want to check whether the data is not found, so what you can do, we put found equals false. Let's change it to big false, and then found is true, and then after that, if not found, you can see print the data is not found. So let's try doing another one. Let's say 90. So data 90 is not found. And what you can do like this. this one we put return 0. This one we can do, I don't know. If you want the program to, the function to return a data, then it's on you. You can let the program return whatever data that you have, whatever the index that you have, back to the user also can. So that's why I put return 0. But since there are several numbers, several possibilities that the data is found, so that's why I just reframe myself to do that. Okay, so let us do another one. Add to n, another add to n of 10. So if you run this, you can see, oh, data 10 is found at index 3 and data 10 is found at index 6, meaning that we have found two instances of data 10, like that. Okay, so this is find data, meaning that we want to find the data in a given index. Let's say we want to get the data from a specific index. Just now we learned how to find the data in the list. Now we want to get the data from a specific index or specific position in the list. Okay, so define get data, comma, index. Okay, so what do? We can just do the same, but we change a bit. This time, we change. Okay, so we already use the index here, so we don't want to change it. So let us keep it at k. K equals to 1. Found also remove because we only want to find a specific position. Okay, and then let's see. So first, k plus 1. Okay, let us ignore this first. So let's say if the data is not found, if the index is, we are not at the index, we are not at the current at the position that we want in the list, so we add another one and we get to the next node. Okay, now for this one, let us do this. If k is equals to is index, meaning that if the current position is the position that we want to find, so let us return this. Print I'll just put the data at position, comma, index is tab node dot get data, this one, comma, dot, and then we can just return data, return tab node dot get data, like that. Or we can just do it like this, return tab node dot get data. But let's say if it's over, meaning that we have we have reached the end and we still haven't found any data. We are not at the current position, or basically, in other words, the position that we are asking is not within the size of the list, meaning that the list is of size 10, but we are searching for the 20th position, 20th element in the list. So we can just say like this, print the list is not the index is outside the size of the list. So let's find list dot get data and then we say 1, and let's just print out this. See, you can see the number 20 here. If I want to put, like, for example, 10, it will say none. The link is outside the size of the list. You can also put return -1 or any other things that you want to do lah. So we have learned about add to start, we have learned about add to end, we have learned about remove data, we have learned about display, we have learned about find data, we have learned about get data. So basically we have learned pretty much the basics of linked lists, where you can define your own linked list and you can do whatever you want with the list. Okay? And there's a challenge here. I just noticed this. I think I give you guys the challenge of this thing, but I did not include it in the task because I know it's very hard for you guys to do this. Okay. So, is there any more questions? Anyone from the? Oh, I almost forgot. I almost forgot about the magic word for today. Give me a moment. So let me give you the magic word for today before we end out. Not before we end our class. Yeah, basically before we end our class lah. So the word of the day is linked to faith. That's the magic word for the day for this session. Okay? So those who are joining the class, you can immediately fill up the Google form. Okay. With that,
You send a form?
we will use the same Google form like before.
Oh, okay. So you point to it. Let me just point to it. Yeah.
Let me just. Where is the link? There you go.
Okay. Same time.
It's okay.
Okay.
So the magic word word of the day is linked to faith. So as for the previous class, there are 13 people who attended. For this class, people are joining. Okay. So Faizal Hashimi, only one. I think there are 8 people here. Wait, I think like someone is chatting here. Let me see. How can I see the chat here? I can't seem to know. What is this? Okay.
Is there any chat? I didn't see any chat here yet. Okay, Azima, can you add me as a collaborator with on this form?
Sure.
So that I can just see it, use it as my
Sure.
attendance also.
No problem. I'll send it to you personally.
That's exactly what I need. You actually send it on the group, right?
Eh, did I send it on the group?
Yeah,
Oh my god.
yeah, you did on the group.
Oh
So you
my
can just
god.
delete it.
Let me just delete that.
Yeah, so you can just send it to me.
Okay, now this is the correct one. Okay, okay. My bad.
All right, okay, thank you. And I think this can be, oh, okay, okay, because you have seen some question. Amir Azik, Amir,
Yes, madam.
why were you missing? I've been looking for you.
Oh, no, just last
Yes.
week I'm really busy. I think I want
Ah,
to meet you maybe tomorrow or the day after tomorrow, madam. Can I?
okay, yes, you can please. You meet me
Yeah.
or try maybe lunch hour, inshallah.
All right, I will try.
Okay, all right, good.
Okay. So is there any questions from the class?
No, for now.
No for now. Are you sure?
Ya, tak try buat test lagi.
Yeah, I think it's better for you guys to try that first. Kena buat dulu. So, and then if there's anything you can ask me. Mm-mm. I do think that
And I don't know whether you guys are actually
mm-mm.
doing the typing. You are trying to type whilst he's explaining, or you're just looking. I want to know what you guys do.
Mm-mm.
Adam,
Si- since the
Adam,
Yes. Yes.
do you type whilst the code is being showed, or you wait until later?
No, during when he's explain, I open a separate slide about linguistics and just cross-reference.
Oh, okay. Cross-reference, not
Yeah,
not
because
not not clear, right?
no,
Who's
no, no.
coding? Who's coding when this is going on? Amir, Amir.
Yeah, madam.
Yes, are you coding?
No.
Oh,
Oh,
okay.
just yet.
That's not the best, actually.
All right.
You
um,
should code so that you get the error and you find yes for everyone,
mm-mm,
actually. That would be the best.
mm-mm,
Because I see when you scroll down up, nobody is talking. So you should code during the class, and if maybe you cannot complete or there is error, uh, then that gives you a good what do you call it? When they say rasa, you you feel it. Otherwise, if you wait until next class or next whatsoever, then it will be so bulky and so much for you, and it's not actually um how will I say, it is not advisable you copy paste code. It's not advisable. So it's better, even though you're going to copy like as we are now, you just start copying. Definitely there will be error because you copy wrongly. But if you type wrongly, but if you copy when this code is maybe in the GitHub or whatsoever, and you copy it, then it's not doing you a good one. Okay, I hope you guys understand. Mumi,
mm-mm.
Yes, madam.
okay. Where is
I,
Jalo? Is Jalo here? He's not here, right? So I think this is what we adopt for every class.
Mm-mm.
So it will actually, inshallah, go slow for you guys to at least, if you cannot meet everything up, but you need to do something in the class,
Mm-mm.
assign this task. Okay.
Mm-mm.
All right. I think that's what I have to share with you
Mm-mm.
guys tonight.
Mm-mm.
And the what do you call it has been uploaded, the project. So the project is about 4 weeks. Okay, so you have time to discuss and to And it's bonus for those who have done it, those who have taken data structure last semester. And I advise you not to take the same question. Afiza, Afiza, where is Afiza?
Yes.
Yes, Afiza, what was your title last semester?
Um, Let me.
You said what?
Um,
You cannot remember?
yeah, I can
Are you in Sarah's
remember.
group? Which group were you?
Yes. Yeah.
Sarah's group. So what was that? So because I don't want you to do the same thing you did last semester. That is not challenging at all. Okay, that's why I remember Pfizer's was knapsack, but maybe knapsack, fractional knapsack, maybe something like that. So better you take something challenging, all right, this time around, so that it's not like you're repeating the same thing. And that's why I say you should do it concurrently. Take the lab together with the data structure, then that's it for you. So you are taking one thing. Okay, Afiza, you have to confirm it's not the same project, okay?
Okay.
All right, okay. I think that's what I want to share. So Azima, you can take over.
Okay, so I'll just stop the recording for now.